Now, the moment you have been waiting for. What's the difference between all these 3D printing technologies and which one actually suits your needs best? With the understanding that there is no such thing as the best 3D print technology, at SEEDA we offer a full portfolio of the most common technologies that should apply to any of your manufacturing needs. But let's start with resin printers, also known as DLP and SLA printers. DLP and SLA are best used when you need highest details in your parts, for example for aesthetic purposes. DLP printers use an HD projector that beams energy at a certain wavelength to harden a liquid resin, resulting in a layer of hardened plastic. The process is repeated each layer with a height of 25 microns, that is 1/40th of a millimeter each layer. You can only imagine how detailed the final part will become. Small counter is that the technology is often limited to a smaller build area. This technology can be used for applications such as small parts, electric connectors, latches and closures, small fittings, small figures, organic shapes, jewelry casting, jewelry prototyping, rubber molding, and small part investment casting. An example of such printer is the XYZ Printing Part Pro 100 series. Some key features include a 6x4 by 12 centimeter build platform, 100 to 25 micron resolution, and manufacturing different plastics including rigid, rubber, translucent, high temp, and casting. Price point of the Part Pro 100 series starts at 2,000 euros. Now let's move on to FFF or FDM 3D printers. FFF is the most available and accessible 3D printing process. This technology is mainly used for low-cost prototypes, validating of 3D printing designs, and small series productions. The advantage of FFF is a wide choice of materials and a relatively fast delivery. FFF can be used for making jigs, tools and fixtures, functional prototypes, customized end-use parts, inspection tooling, miniature models for production, or miniature models of products which you can use for sales purposes. But really, FFF printers are the type that has the widest range of applications, thanks to its wide range of material usage. Examples of FFF printers are the Part Pro 300 and the Ultimaker S5. Let me give you some details of the Part Pro 300. It embeds a 30 by 30 by 30 centimeter build volume. It has a heated build chamber, and it runs materials such as carbon fiber, metallic materials, ABS, tough PLA, PET, but also nylons and polypropylene. Another great printer is the Ultimaker S5. It has a build volume of 33 by 24 by 30 centimeters, and it has its own material range designed by Ultimaker, which include PLA, tough PLA, nylon, ABS, CPE, CPA+, PC, TPU 95, PP, and PVA, amongst others. This model has active auto leveling and also includes the best dual extruder system in the market for combining two materials in one build. Then there's binder jetting technology. Binder jetting is the most used technique for full color parts. Binder jetting offers complete design freedom. The way it works is that a layer of gypsum powder is equally spread on the build bed. After, the printing head simultaneously colors and glues the powder into the desired model shape and color. This process is then repeated layer after layer, resulting in a beautiful colored 3D printed object. Binder jetting offers applications in rapid production of figurines, architectural models, landscaping, industrial design studies, medical models, color assembly, and marketing applications. Our flagship binder jet printer is the XYZ Part Pro 350 XBC. It features a 35 by 22 by 20 centimeter build volume, and it can do millions of colors. It is Truly the fastest, low-cost binder jet 3D printer on the market. Finally, there is SLS. It's probably the most sought-after technology of all. SLS is widely used for both prototyping and small batch productions of functional plastic parts. SLS offers improved mechanical properties and also offers the designer complete freedom in design, unlike other techniques. A layer of powder is evenly spread over the building surface and then heated up to just below melting point. A powerful but precise laser then fuses the powder particles together to obtain the desired shape. This process is then repeated each layer until the build is completed. SLS technology can be used in the following applications: rapid manufacturing, aerospace hardware, UAV, and much more. Examples of SLS printers are our MFG Pro 230 by XYZ Printing and the Sinterit Lisa. The Sinterit Lisa features an 11 by 10 by 15 centimeter build volume. It is equipped with a reliable diode laser and it has a relatively small footprint, and therefore we refer to it as a desktop SLS printer. Then we have an industrial SLS printer, such as the Manufacturing Pro 230 by XYZ Printing. This features a 23 by 23 by 23 centimeter build volume and is equipped with a 30 watt CO2 laser. This printer is also equipped with an open material system, so you can test a wide range of powders, even which are not generic by XYZ Printing themselves. Even though we spent a lot of time making this video guide, we understand that it might not be the complete picture that is applicable to your situation. And maybe you will need more information to decide which machine is most applicable to yours. So with our expertise, we can help you pave the way to make the right decision into implementing additive manufacturing technology at your site. At SEEDA, we strive to offering the most cost-effective and quality 3D printers like the ones I mentioned earlier. And if this is what you're looking for, book a free consultation with us by clicking the button below and filling out a very small form. We really look forward to hearing from you, and remember, book a meeting today because our consultation times are often very limited. Thank you for watching and hope to speak to you soon.